All right, everyone, here's a homework problem from homework number 13. It says the probability of a randomly selected adult in one country being infected with a certain virus is 0.002. In tests for the virus, blood samples from 28 people are combined. What is the probability that the combined sample tests positive for the virus? So let's start there. We're talking about the way people test for a virus. So, for example, imagine an airplane coming into the United States and they suspect somebody could be infected with, I don't know, the Ebola virus or something. Rather than testing each person individually, they would take a big group, a little sample of blood from each person, and then mix it and test that one sample. If it were positive, then they'd have to go back and test people individually. But if it turned out negative, then they'd know everybody in the group was negative and they could let you go. So all it takes is one person in the group to affect the results. So as I think is a good idea for all of these problems to start with a probability distribution, even though we will not figure out the whole table, it at least helps us visualize and see a little better what we need to do. All right, because this is a binomial and we're going to use the binomial formula, we need to know four things: n, p, q, and x. And we're actually going to start back over at the probability distribution and define x. So, always want to start here. In this case, x is going to be, let's let x be the number of people. Remember, x is always a finite, countable value. It is the number of people who test positive, okay, for the virus. Test positive or have the virus, however you want to think about it. So if you can remember, P, which is the probability of a success, it always links up with x. If x is the number of people who test positive, p is the probability someone tests positive, and that value is actually given to us right here, 0.002. And then we know that q, which is the complement of p, it is the probability someone tests negative for the virus. That is going to be 1 minus 0.002, because their complements, their probabilities, will always add up to 1. So the probability someone tests negative for the virus is 0.998. All right, what is n? Well, n is the number of people that we're going to test. It's right here. It's going to be the number 28, and it's also, n will always be our list here of x. We're going to test 28 people. So what are all the different possible outcomes? We know, for example, that we could test all the people and 0 people test positive, and all 28 test negative. One person could test positive and the remaining 27 negative. 2 people could test positive and the remaining 26 negative, and so on down the line, all the way down here to 28 people could potentially test positive. The remaining 0 would test negative. Right? So this is our probability distribution, and for each one of these values, we would do the binomial formula to find it. We are certainly not going to take the time to do that. We have to now go back over and decide, what do we want to figure out the probability of? What is x? Well, the question is, what is the probability that the combined sample would be positive? So in other words, what is the question? What is the probability of a positive test result? Well, in this case, all it takes is one person to test positive to make the whole sample positive. So that would mean one person or 2 or 3 or 4. Any one of these results would make our test positive. It would take a long time to figure out all these probabilities. So what might be a better option? Let's find out the one situation that would make the test result negative. What is the probability that x, in fact, equals 0? It is when x is 0, when not one person tests positive, all 28 people test negative. That is the one situation where you would get a negative result overall. So if we can figure out the probability of this value right here, we can subtract it from 1 because we know the sum of all the probabilities is equal to 1. So if we can subtract this value here from 1, we'll have the probability of all these other numbers, and that hence the probability of the test being positive. So let's take a minute and do that. We will actually use technology to help us, but in the meantime, we'll just at least set it up so we have an understanding of what's going on. So using the binomial formula, we know that the probability that x equals 0 is equal to n choose x. In this case, n is 28. Choose x. In this case, x is 0. We're trying to find the probability that nobody tests positive. P times P. P in this case is 0.002 to the power of 20, to the power of 0, to the power of x, times the probability of Q, which is 0.998, to the power of n minus x, which is basically 28 minus 0, which is 28. 28 people would be testing negative. All right, so we talked about this before. You can plug this into your calculator and see what you get, or you can use technology, which is what I'm going to do here with StatCrunch. So let's go through a quick review of how we do this in StatCrunch. We want to open a StatCrunch page. Using your StatCrunch tips, you can click on Stat Calculators. We have a binomial calculator. Click on that. Bring it over here. In this case, we fill in the values, and for this problem was 28, and the value of the probability of success, which in this case was getting the virus, testing positive for the virus, that was 0.002, and we wanted to find the probability that or that x equals exactly 0. Nobody tests positive. We compute that and we get a value of 0.9454. 0.9454. So let's put that right in here. 0.9454. So that was this value right up here. The probability of nobody testing positive is 0.9454. So therefore, what is this probability of everybody else? Of one person having the testing positive, or 2, or 3, or 4, everybody, because it doesn't matter. All of these are going to give us a positive test result in the combined sample. So if we take 1 and we subtract 0.9454, 9454, we will get a value of 0.0545. 0.0545. So there you go. Is it unlikely? So this is the probability that it will test positive. 0.055 approximately is the probability of a positive test result. And the question then becomes, is it unlikely for such a combined sample to test positive? Well, we have our 5% rule, which is that line where things become unlikely, and this is actually slightly greater than 0.05. So while it's close to being unlikely, it would not fall into the category. So we would have to say this is actually not an unlikely event. That one person that the sample could be positive. So give it a try.